In 1990, after years away, ecologist James Estes returned by boat to the shores of one of Alaska's most remote islands. Estes had studied sea otters there for 2 decades and had grown used to seeing their small brown heads constantly popping up among the kelp beds along the coast. But this time, everything was different. Estes raised his binoculars. 1 minute, 10 minutes, then hours passed. The surface of the sea remained strangely still. Surveys later confirmed that more than 90% of the sea otters had disappeared. Estes and his team immediately expanded their search. They flew along the coastline, swept lights across rocky cliffs, and repeatedly analyzed water samples. But the strange thing was that they could not find anywhere near enough bodies to explain the scale of the loss. There was no major disease outbreak, and it did not appear to have been caused by humans. 200,000 sea otters had simply vanished, and no one could explain why. At the same time, Estes began noticing that many smaller organisms in the coastal ecosystem were also becoming increasingly scarce. From the air, ecologist Robert G. Anthony was equally stunned to realize that the extremely rare bald eagles were disappearing as well. Where had everything gone? Was this all just a coincidence, or had some ocean monster triggered this entire chain of consequences? This was not the first time sea otters had disappeared from Alaska. 2 centuries earlier, their valuable fur had turned them into victims of one of the most brutal wildlife massacres of the era. Millions vanished. It was not until an emergency international treaty completely banned hunting that they were finally saved. From just a few hundred survivors on the remote island of Amchitka, their population made a remarkable comeback. By 1980, more than 70,000 sea otters had spread across the Aleutian Islands. Scientists proudly called it one of the greatest conservation victories ever, until the tragedy of 1,990 struck. But to understand why the disaster became so severe, we first need to understand James Estes's most important discovery. During his dives around the Aleutian Islands, he noticed something strange. Areas with many sea otters looked so different from places where otters were scarce that they seemed like 2 entirely different ecosystems. One was green and bursting with life. The other was far more barren and impoverished. Were the sea otters responsible for creating this difference? Later, other scientists would discover that they played several other important roles as well. In less than a decade, the population fell from around 77,000 individuals to just 2,442. A population that had once been thriving had nearly vanished. The sea otters had disappeared too quickly, too cleanly, as if something enormous had simply swallowed them up. But uncovering what had happened was far from easy. At first, scientists suspected starvation, yet the surviving otters were actually healthier, with more food available to them. Disease also left no signs large enough to explain the collapse. The 1,989 Exxon Valdez oil spill had killed thousands of sea otters in Prince William Sound, but the decline in the Aleutians covered a much larger area and did not match the extent of the spill. Fishing nets or accidents could not explain it either, because far too few carcasses were washing ashore. We now know that something was eating them, but scientists still couldn't confirm which predator was responsible until they reached Adak Island. There, Clam Lagoon is a shallow, enclosed body of water, while nearby Kuluk Bay opens directly into the sea. For years, the sea otter population inside Clam Lagoon remained relatively stable, while in Kuluk Bay it declined by as much as 76%. Same island, same climate, same food supply. The biggest difference was that a massive killer whale would have a much harder time entering the shallow lagoon. Then, one by one, the hidden cameras they had set up began producing the evidence they needed. Between 1,992 and 1,996, Brian Hatfield and his colleagues documented 9 killer whale attacks on sea otters in the Aleutian Islands and Prince William Sound behavior that had rarely, if ever, been directly described in the scientific literature before. Mammal-hunting orcas also had a terrifying advantage. They often approached their prey in silence, reducing their calls and echolocation because other marine mammals can hear them. A sea otter weighing only a few dozen kilograms might be floating among the kelp with almost no warning at all. From deeper water, a body several meters long could silently close in. In the recorded observations, killer whales rushed into areas where otters were floating or hiding in the kelp. The chase unfolded in seconds, and then the otter disappeared beneath the surface. If the hunt was successful, there was no intact carcass left to wash ashore. The animal had been consumed at sea. That helped explain how thousands of sea otters could disappear, while the beaches showed almost no corresponding number of bodies. At first, Estes still found the idea hard to believe. Why would a killer whale weighing several tons bother hunting such a tiny sea otter? But when the research team plugged the numbers into a model, the answer became chilling. To produce the decline observed in part of the Aleutians between 1,991 and 1,997, killer whales would have needed to remove about 6,788 sea otters each year. Based on the total amount of time researchers were actually present to observe the ocean, the model predicted that they would have had a chance to witness only about 5.05 attacks. In reality, they recorded 6 within the area, analyzed an almost exact match. Even more alarming, the energy model showed that it would not take hundreds of killer whales, the equivalent of only about 7 individuals in practical terms. A small group of roughly 4 to 5 whales regularly adding sea otters to their diet could theoretically have been enough to produce the collapse that was observed. Just a few apex predators changing what they ate could cause tens of thousands of sea otters to disappear while leaving almost no trace behind. The mystery of the missing sea otters had been solved, but many other small creatures from fish and crabs to mussels and clams, and especially the bald eagles overhead, were also disappearing one after another. How could killer whales have caused all of that? That is the next question we will explore. But before that, we need to address another mystery. Killer whales have existed in the ocean for millions of years, so why did they only recently begin eating so many sea otters? In reality, not all orcas hunt them. The main suspects are transient killer whales, which specialize in hunting marine mammals and normally prey on seals, sea lions, dolphins, and even other whales. According to NOAA, the diet of each orca group is shaped by culture. Hunting techniques are learned and passed down within the pod. And just before the sea otter collapse, their larger prey were disappearing as well. Western stellar sea lions once numbered at least 140,000 between 1,956 and 1,960. But by 1990, only 30,525 remained, a decline of nearly 80%. Harbor seals across 106 Aleutian Islands also fell from 8,601 to 2,859, a 67% decline. In the Western Aleutians alone, the drop reached 86%. In 2003, James Estes and his colleagues proposed an even broader hypothesis. Industrial whaling after World War II had reduced great whale populations, causing some killer whales to put increasing pressure on smaller prey, shifting from whales to seals, sea lions, and eventually sea otters. But this remains a controversial hypothesis. A 2007 analysis argued that the timeline was not strong enough to prove that commercial whaling directly forced orcas to change their diet. When sea otters disappeared from the Aleutians, the first thing to change was not the killer whales, it was the seafloor. For decades, sea otters had quietly kept sea urchins under control. Once this key predator disappeared, the urchins immediately filled the gap. At a dock, sea urchin biomass increased by about 8-fold. Surveys across 8 islands found only around 15 urchins per square meter in the remaining kelp patches, but in areas that had already turned into barrens, the average rose to about 114 per square meter. Brenda Konar even recorded some places with nearly 400 urchins per square meter. Underwater, the seafloor was no longer green. It was covered with moving purple dots like a living carpet, and then they began to eat. At first, they grazed on the tender tissues and blades of the kelp. Then they moved to the stipes and the areas around the holdfasts, where the kelp anchors itself to the rocks. When hundreds of urchins grazed within a small area, the kelp had almost no chance to recover. At a dock, kelp density fell by more than 12-fold. In 1991, the rate of kelp tissue loss from grazing was only about 1.1% per day. By 1997, it had risen to 47.5% per day, more than 40 times higher. Within just a few years, forests that once swayed with the waves had been replaced by bare rocky areas known as urchin barrens. What was frightening was that the ecosystem did not decline gradually. It seemed to cross a threshold. After the Exxon Valdez oil spill, Prince William Sound once lost about half of its sea otters, yet the kelp did not collapse in the same way. That suggests an ecosystem can tolerate losing part of its predator population, But once sea otter numbers fall too low, sea urchins escape control, and the entire ecological state can flip into a different world. The loss of kelp pulled down the entire web of life around it. The kelp beds that once provided shelter and nursery grounds for cod, rock greenling, and many bottom-dwelling organisms disappeared, changing the structure of the fish community. The effects even reached into the sky. When Robert G. Anthony, James Estes, and their colleagues compared bald eagles on 4 islands between 1993, 1994, and 2002, they did not find a collapse in the number of breeding pairs. Instead, the eagle's diet changed dramatically. Sea otter pups and certain fish became less common in their diet, while rock ptarmigan, glaucous-winged gulls, Atka mackerel, and various seabirds became more common. A disturbance beneath the water had traveled through at least 5 trophic links before reaching an apex predator in the air. But the urchins still were not finished. After the kelp had been grazed nearly bare, they began feeding on Clathromorphum nereostratum, a calcified red alga that forms the foundation of Aleutian reefs. Some of these structures are several meters thick and have accumulated over thousands of years. The urchins scrape and bore into them faster than the reefs can regenerate, and in some places, these ancient reefs are beginning to crumble. Warmer and more acidic seawater also weakens the calcium carbonate structure, causing grazing under modern conditions to be about 35–60% greater than under pre-industrial conditions. The collapse, therefore, was not just erasing a forest. It was beginning to destroy the very foundation that had taken centuries or even millennia to form. And the surviving sea otters did not return to their old way of life. By 2015, densities in many declining areas had fallen to only about 5% of the environment's carrying capacity. They clustered close to shore, choosing lagoons, shallow water, and complex rocky terrain places where killer whales had more difficulty reaching them. A predator does not need to kill every sea otter. Simply forcing the survivors away from open water is enough to weaken their ecological role. The otters are still there, but there are too few of them to control the urchins and maintain the kelp forest. A species may not be extinct, but functionally the ecosystem has nearly lost it. This was the point where the problem became almost impossible to solve. Scientists knew the sea otters needed to be saved, but the culprit was not an invasive species or a harmful pest. Killer whales are native apex predators, play an important role in this same ecosystem, and are also protected under the Marine Mammal Protection Act. Humans could not hunt, kill, or simply remove them to save the sea otters. Scientists had identified the cause, but they could not eliminate it. Even so, people still had to do something. If killer whales could not be removed, there was only one option left: help sea otters survive in the same waters where their predators still remain. The first major step came in 2005, when the Southwest Alaska population of sea otters was listed as threatened under the Endangered Species Act. From that point on, the goal was no longer simply to count how many were left, but to protect the places where they had the best chance of surviving. Scientists quickly recognized something important from places like Clam Lagoon. Geography itself could become a shield. A killer whale several meters long may dominate open water, but it cannot easily charge into shallow lagoons, enclosed bays, or rocky reefs close to shore. So in 2009, the United States officially designated about 15,164 square kilometers, or 5,855 square miles, of coastal waters in southwest Alaska as critical habitat for sea otters. Most of this area lies close to shore, extending from the tidal edge out about 100 meters or to depths of roughly 20 meters. More importantly, the U.S. Fish and Wildlife Service identified the ability to provide shelter from marine predators, especially killer whales, as one of the essential features of the habitat. But protecting natural refuges still might not be enough. The recovery plan later proposed an even bolder idea: creating predation refuges, areas where killer whales would have difficulty entering or hunting effectively. These could include shallow lagoons, rocky reefs, or embayments connected to the sea through only a narrow channel. Survey data showed that in some places like these, sea otter populations either did not decline or declined more slowly than in open water. The plan even considered building additional artificial refuges, or installing predator exclusion devices in narrow channels in principle, something like creating a doorway that small sea otters could pass through, but a massive killer whale would have difficulty crossing. This remains mainly a management option under study, rather than a system of anti-orca barriers spread across the Aleutian Islands. A seemingly simpler solution was also considered: capture sea otters from healthy populations and move them back to islands where too many had been lost. Humans had successfully done this in the 20th century to re-establish sea otters in places where hunting had wiped them out. But in the Aleutians, the problem was still waiting beneath the surface. If killer whales continued to control the open water, releasing more sea otters might simply mean adding more prey to the same trap. That is why the recovery plan requires that before any translocation takes place, managers must evaluate the release site, the source population, the genetic consequences, and most importantly, whether the threat there has been reduced enough. For that reason, this recovery effort does not have a simple moment where animals are released and nature heals itself. People have to preserve every safe lagoon, every stretch of shallow coastline, and every remaining group of sea otters, while also reducing other risks such as oil spills and vessel activity. They cannot remove the predator that stands above the sea otter in the food web. In 2020, nearly 3 decades after scientists first suspected that killer whales were behind the collapse of Aleutian sea otters, an unexpected piece of evidence washed ashore. On April 14, on Bering Island in Russia's Commander Islands, the carcass of an adult female killer whale was discovered. During the necropsy, researchers found 6 nearly intact sea otters inside its stomach. A 7th was lodged between the mouth and the esophagus. Altogether, the 7 otters weighed about 117 kilograms. Scientists believe the otter stuck in the esophagus may have contributed to the whale suffocating. This was the first direct evidence of a killer whale eating sea otters in the Commander Islands. It does not prove that this particular whale was connected to the Alaska collapse of the 1990s, but it turned what had once seemed like an unlikely hypothesis into a chilling image. A killer whale could swallow several sea otters in succession, leaving almost no carcasses behind for the waves to carry ashore. But that evidence did not mean the story was over. A 2023 USFWS report estimated that the entire Southwest Alaska stock contained about 51,935 sea otters. However, that number covers more than 2,500 kilometers and combines surveys conducted in different years. It does not mean the Aleutians have returned to pre-collapse levels. In the Western Aleutians alone, the epicenter of the decline, a 2021 survey, estimated only about 2,405 otters. The Eastern Aleutians had about 8,593, Bristol Bay 9,733, and the South Alaska Peninsula only about 546. USFWS considers the Western Aleutians population low but stable, while the South Alaska Peninsula is still declining and the Eastern Aleutians and Bristol Bay are increasing. Just a few hundred kilometers can separate an area that is recovering from one where sea otters remain extremely scarce. Underwater, the consequences are even more obvious. Brenda Konar, who has been diving in the Aleutians since the period when sea otters began to collapse, described a place that once had kelp forests stretching for miles. By 2020, she said that kelp forests in many parts of the central and western Aleutians had essentially disappeared, while some sites recorded around 400 sea urchins per square meter. After stripping away the kelp, the urchins continued feeding on clathromorphum, the calcified algae that forms the foundation of the reefs. In some places, reefs several meters thick, built up over thousands of years, are being eroded right in front of divers. So the fact that sea otter numbers have stopped declining does not mean the ecosystem has returned. The otters may still be there, but there are still too few of them to perform their former ecological role. And by 2026, the U.S. government still had not closed the case. On April 8, USFWS launched a new 5-year status review of the Southwest Alaska Northern Sea Otter, requesting the latest data to reassess the population under the Endangered Species Act. This is a routine review, not a declaration that sea otters are collapsing again. But more than 30 years later, the fact that they still require close monitoring shows that this story has no neat ending. The sea otters survived, and some regions are increasing. But in the Western Aleutians, urchin barrens remain, ancient reefs continue to erode, and small groups of sea otters still cling to shallow coastal waters. How many sea otters will it take before the underwater forests truly return? In the end, killer whales are not monsters, sea urchins are not invaders, and sea otters never actually planted the kelp forests. Each species is simply doing what millions of years of evolution shaped it to do. But when predation pressure changed, sea otter numbers fell, sea urchins escaped control, kelp disappeared, the food web was disrupted, and even ancient reefs that had taken thousands of years to form began to erode. The story of the Aleutians shows that an ecosystem does not need to lose dozens of species before it collapses. Sometimes, losing just one critical link that holds everything in balance is enough to transform the entire world around it. And if sea otters return in large enough numbers, could those underwater forests recover to what they once were, or have the Aleutians already crossed a point that nature may find extremely difficult to reverse? Do you think humans should intervene more aggressively to save the sea otters? Or should we allow the ecosystem to find a new balance on its own? Let us know what you think in the comments. If you enjoy stories about how a single species can transform an entire landscape or ocean ecosystem, subscribe to the channel and stay tuned for the next episode in this series, because there are still many ecosystems around the world quietly changing in ways that are almost impossible to believe.